Now, I've been setting the wheel alignment on my Land Rovers for quite some time, mainly on my other car. I haven't actually touched this one. I've always thought there had to be a better way, but I can make some form of alignment tool to actually make the process easier. It's quite an elaborate process to go through if you do it by hand, but I always prefer to, as you never really know what you're going to get when you take it to a service centre. So I've been putting it off for a while, but this week the lower suspension adjusting bolt came loose at the front on this car. Necessity means that I must do it now. So what I plan on doing is creating a mount so I can mount a laser pointer to the centre of the wheel, and that will draw a straight line. What you normally do is you set a parallel line with string, which I'll do as well, from the centre of the hubs, and then if I can make a mount to go on the centre of the hub, I'll have an alignment for my towing and also for my camber. So just to be clear, this isn't a full wheel alignment. It's just a process to actually get this car drivable again. It's now throwing an error on the dashboard to say that the steering wheel's not pointing in the same direction as the wheels, which is not good. It won't take long to scrub the wheels out. So we'll just correct that. In the future, I'll do a longer video explaining the full process of aligning. It's pretty involved, but I find it worth doing. Okay, so the problem is that obviously Land Rover make a lot of different wheels for this car. To reverse engineer the wheel, it's really quite involved and just not worth doing. It could take you hours to do it. But with a 3D scanner, I can scan the wheel and create a mount, and then also do the same on my other car, which has got a different style wheel. In the future, I don't need to do the alignment on that car at the moment, but maybe in the future I'll have to. I'm going to use my Creality Otter Lite to do the scan, and that I think will give us a good result. But anyway, here goes. So let's get down to scanning the wheel. It's important to ensure that the wheel isn't buckled before you start scanning. I've heard some suggestions that giving it a good clean is a good idea. In actual fact, that's not true. What you want is something for the scanner to pick on as being a difference, so keeping it dirty works quite well. And this is dirty. So just scanning and trying to get as much in as I can from various different angles. And this is the result on my phone. This is actually a point cloud, so if you zoom in closely you can see the gaps between the points, but that should be enough information to do what I want to do. You can see the contours on the centre of the wheel there. So this is the point cloud fresh from the scanner, loaded into my PC. You can see there's quite a bit of information there that we don't really need. The wheel arch and some ground. So I'll use the connected components tool. You click the part that you do want to keep. You invert the selection and then that deletes unwanted data, but you can still see some of the flaw there, so I'll use the loop tool to draw around it, just around the tricky bit there, and it turns it red, and then we delete that too. Okay, that's pretty much all we need, apart from this ragged bit at the back. That's just a bit more than we really need, so I'll cut that off too. Just loop around it and delete. Okay, so the next part of the process is to fuse it. I'll run Fusion. Use the default settings. There we go, and that looks more like a wheel. Got the tread and things. I don't need the tread, but it's interesting to see it. And then we do a meshing. The mesh is the final process before you can export it as an STL or an OBJ or something similar. And there's the finished wheel. I'll export the model and save it as an STL. So we land in Fusion. First thing to do is start a new job and make it a hybrid design. And then we go to import mesh and then find the file where you saved it, and that was mine. And there's the wheel, so we'll center it and ground it, and then I like to manually adjust it, so go to the face and put in 63, I think. Yes, 63, that would do it. And there's our mesh. Lots of triangles in this at the moment, so we need to reduce it. I'm going to reduce it to 10%. That's a less dense cloud, but still enough to give the detail that we want. And then we convert it to a body. This can take a little time. I've cut it down here. Okay, and there's our body. You can see all the triangles. It creates a sort of a faceted surface, but it's good enough for our purposes. And what I did there was to convert the body that was just created into a component. And we can draw a plane. So we want a plane through 3 points to get it so it's flat to the rim. Where's it gone? There it is. So we can zoom in and pick a likely looking point. Go with that one, I think. That's point 1. Stick one over here. Somewhere. Maybe that one. That's our second point, and then when we click our third point, it will create the plane. That one. Okay, so that's our plane through 3 points, and that should be pretty accurate. You can fiddle around with that if you're not happy with the accuracy, but I'm good with that. So then we want to go to solid, drawing on the plane. Start off with the circle somewhere in the middle. That's roughly right. It doesn't need to be 100% perfect for this. And we'll make that 200. It could be anything you make your mind up about this. That's just what I've decided on. And then a rectangle from the center point. Make that 80 high and 300 wide, yeah. Okay, so then we extrude that as a solid. Go down 20. And there we've got a body which intersects the wheel at the moment. Now we need to cut that, so we go to split body, select that as the part we want to cut, and this is the cutting tool, which is the wheel. This takes ages, and I've cut it short there for you. Okay, so there we've got our body, which is intersected by the wheel. We'll turn the wheel off and you can see the line where it made the cut. Turn off the body that we don't want, which is that one. And there you can see it. Again, you can see it's tessellated, but that matches the wheel exactly, and it's good enough for what we need. I've gone too deep there. Doesn't need to be 20, probably needs to be more like 10. But I can go back in the timeline and edit that. So that gives us our mounting block, which will butt up perfectly to the wheel. So this is just a very quick design of a clip to hold my laser pen. You could design anything to mount to it really if you got a bit more elaborate, but this is just a clip and it takes my laser pen, and you can add spacers to it to bring it further out from the wheel if you want to. So this is the final result after 3D printing. I've added in the laser pen holder, and you can see there the contours. I did lower it from 20, that was far too much. I think it's actually gone 10 in now, and that will make a very snug fit on the wheel. You can see the layer lines, that's from the 3D printer, but that's of no consequence, it doesn't matter. This is not my full setup for an alignment. I'm just doing it here because I had to realign the front wheel. The lower wishbone bolt had come undone and I'd lost tracking, so this is why I'm doing this. But that yellow line there is set up so that it's parallel. You measure from the center of each hub to get a parallel line. And you can see here that's just the laser pen pointing at the other wheel. But that's not the critical measurement anyway, really. So this is with the tool on the front wheel, and you can see here that's the line that the pencil line is the parallel line. The ruler is slightly toe out at the moment. That's no good. We don't want that. We want toe in. So I'll have to put the car up and loosen off the bolt and adjust it so that it goes toe in. I'm pretty sure with this tool I can do a fine adjustment of the angle of tracking, and this will actually help quite a lot in doing that. And there's the offending bolt. So when I adjust that adjusting bolt, you think you can see here that it is now toe in. That's the ruler was set to the line that before I adjusted it. And so now we've got toe in. It doesn't need to be very much, it's surprisingly little, but makes a big difference. So there, that worked. So obviously there are other ways of doing this. You can put a straight edge across the rim, but it doesn't give you the ability to draw a line on the floor in the way that I showed. And I have a 3D scanner, so I thought I'd use it for this application, which I bought myself, by the way.